All right, folks, today I'm working on the DM2000. This is another giant console audio mixer. And some of you might be familiar with my Control 24 repair video, which I did many years ago and has proven to be quite popular. This was given to me by Victoria and Matt. Shout out to Victoria and Matt. Thank you so much. I'm going to be fixing this for a donation to another center. And they told me that they don't want it unless it's working. So, sometimes you gotta put in a little bit of extra elbow grease. And I'm confident I'll be able to fix this. It's a similar issue, I believe, as the Control 24. I'll go over that in a minute. It's a fader issue. But first, I want to show you how to set this up in computer software so you can communicate between this and the computer to change the faders. Because that's what I needed to do to actually troubleshoot this. I need to see what faders are broken. And that's really hard to do if I don't have it set up as a DAW, what you call a cute puppy, also DAW, Digital Audio Workspace. And so I need to hook up the USB cable, which is a USB type B cable, like a printer style cable, to my computer and have software communicate with this and sort of back and forth bidirectional communication so that I can move the faders in software and see how the mechanics of them are failing here in the hardware. And there's a great video on YouTube by Sound number 4 letter U AV, which is how to set up DM2000 in DAW Control Surface in Logic Pro. So thank you for that video. It was a huge help to me. But I want to break it down for the super noobs like me, step by step like that video does. But I'm going to do it this time using Reaper Audio. Reaper.fm is free audio software. You can pay, I think, if you should buy it. It's like really cheap. It's like $60 or something for the premium version. But there's a freeware version. It's amazing, and it's like a 2-minute install and a super fast download. It's not like bloaty like Logic and Pro Tools and some of these other audio workspaces, software. So I really like it. It's extremely good for tracking, really easy to test with. Reaper.fm, it's awesome. I couldn't find a video on how to set this up for Reaper, so I'm going to show you. There were some forum posts, by the way, that were helpful, but not for total noobs like me. So I'm going to do this the best that I can. Keep in mind, I'm still a pretty big noob at this. We've got our layers over here, 1 through 24. Make sure that's on. And you'll have this screen after you start everything up. And we'll zoom in here to the display, which hopefully you can make out pretty well here. Yeah, I think that's looking pretty good on my screen here. And we're going to look at the buttons over here on the left, and we're going to click Setup. And I'm actually cycling through the tabs, so let's go back to that first tab, which is actually where I wanted to be. Okay, we go here to Setup, and then we press, F4. And that gets us into the MIDI host tab. Now, depending on if you're using a Mac or a PC, you're going to use the jog dial, which is the big dial right here. And you're only going to use, to do this process, you're going to need the jog dial, the enter button, and the arrow keys over here. That's it. So I'm not going to pan the camera back and forth to those, just letting you know what those are. So jog dial, there's an enter button, there's some arrow keys. So over here, you can go up here with the arrow keys, and you can see you can choose between PC or Mac. I'm using a PC, so that's what I'm going to select, enter. You want to make sure that RX port and TX port both say MIDI, and then you'll go over to where it says DAW here, and you can change with the jog dial where that goes to, and you want to make sure it lands on USB 1-4. In the video I saw, it said USB 1-3. I don't think it matters. Yeah, I don't know why the other YouTube video said that. And then you also want to make sure that down here under Remote 1 it says Pro Tools, and that's just that is actually compatible with Reaper and Logic and some of the other stuff. So it already says Pro Tools, cool. So now we'll go back to where it says. I'll try to turn the tripod here again. Go back over here where it says the layer keys are, and we're going to select Remote 1. All right, just click that one button. We'll go back to our display. And then if everything's happy, we're going to get a display that looks like this. And it's going to say, DM2000 has gone offline and is waiting for MIDI input. Okay. So now we're ready to go to our software, which in this case is going to be Reaper. And as you see, I just opened up Reaper, if you might have heard that. And this fader started moving up and down kind of rapidly, which is what I would expect from a broken fader. And that's what I'll be fixing. But before I do that, of course, wanted to show what the audio workspace looks like. All right, so I'm going to go over to my laptop here. By the way, this box is a super convenient way to attach a lamp, because it has the original box with it right now, so that's what I'm using. Let's see if I can do this in a way that makes some sort of sense. Maybe you have to pull the laptop forward here. All right. So, still got to move this in a different way. Bear with me, folks. I might make this a two-part video. This will be maybe just the setting this up, and then I'll do a second part for the actual mechanical repair. So that way, this video isn't too long. Maybe. I don't promise anything because I hate doing video editing, but we'll see. So here's a song I was working on previously. Doesn't matter if you have a song or not. What you're going to do is go into Options and then down to Preferences. Now, unlike when I was using my Digidesign M Audio station, that was really easy to configure. I would just go to the audio. What is it? The device tab under Audio and change the audio system to ASIO. That's what you do if you have a totally different system, so ignore that. I'm just saying it was easier. No, with this, to set this up, first you want to go to, under the audio tab, go to MIDI devices and make sure all these MIDI devices are disabled. There's 0 through 7. And I'm sorry, let me back up. Rewind. First, you want to go to the Yamaha DM2000 downloads web page. Download and install the driver for this, and then plug in the USB cable and make sure that's all finished. If you don't know how to install drivers, man, I don't know. That's pretty newbie. Hopefully you do if you're watching this video. Yeah, I'm not going to show that because that's just too basic. But basically, if you've got the driver installed, that you can find, I'm sure, information on how to do that. But basically, make sure that if your driver is installed correctly, you'll see that it says Yamaha DM2000 here for the MIDI devices. You'll also see it under your devices manager under sound, audio, video devices if you're using Windows. It's a super easy install. It's hard to screw up. You just match your operating system, download it from Yamaha's website. Hopefully that isn't a hard part in this video. So anyway, make sure I'm going to continue now. Sorry for that caveat. Make sure your driver's installed. So yeah, you've got all these Yamaha MIDI devices, and make sure they're all disabled because we're going to be using some of those ports to communicate with this guy. And so now we scroll on the left-hand side of Reaper Preferences all the way down to the bottom, and we're going to click on Control/OSC/Web. I think if you have an older version of Reaper, this is named Control something else. Doesn't have the /OSC/Web. You go in here, and we're going to set up some HUI devices. And so we go to Add. We go to Yamaha as the control surface mode. MIDI input, we'll choose 1, and then also 1.
And then you're going to, for surface offset tracks 0, and then size break is 8. Click OK. I'm actually going to click cancel because I already did it. But you'll see here, this is the working one I did before. So you've got DM2000-1 for the MIDI input, DM2000-1 for the MIDI output. Surface offset 1, fader count 8. Okay. You're going to add, and you're going to have a second one here. MIDI input DM2000-2, MIDI output DM2000-2, the same. And then here for the surface offset, you have 9, and then 8 as the fader count. And so, by the way, the reason we're doing this is there's 3 banks of 8 faders, which is why it's a 24-channel mixer. 24 total, 3 banks of 8. And so this is the way you're telling it that there's these 3 banks. But, you know, the second bank starts at 9, since the first bank is 1 through 8. And then the third bank here, very similar. Just DM2000-3 is the MIDI input, DM2000-3 is the MIDI output, and then you do 17 as the surface offset, and fader count is 8. Once you do all that, click apply. You don't need to change anything else. It should be set to 15 Hertz for the update frequency. That's the default. And you should be good to go. I didn't have any issues after doing that. And if we go back over here, we will see, hopefully, that, increase my brightness here, that I'll be able to control these faders. Unless there's no justice in the world. So yeah, you see now I'm able to turn the fader on my laptop here, and with my mouse, I'm just picking one of the, in this case, this is the second fader, and just moving it up and down on the computer, which in turn moves it up and down on the console mixer. Pretty basic stuff, but I think it's super cool, and I like doing it. I'm just like, yeah, look at something just feels really cool about doing that. Look at it go! Look at it go! So, yeah, and then, you know, we've got a bunch of these guys, right? And so I just went here and I moved every single one of these, just like I'm doing right now. And just to make sure they all work. And as you can see, they're all doing fine. By the way, they call this ghost riding the fader. Just kidding. If anybody remembers that old reference. And there you go. So yeah, there you go. Getting your DAW set up. That's where I'm at so far. And then I'm gonna do a part 2 of this video where I'm actually going to be taking this apart. What you basically need to do. Oh, I didn't show you I'm going to show you the problem again. I showed it briefly for a second, but fader number 1 appears to be the only one that has an issue. And you see it there. If I try to bring it all the way down, I'll go ahead and zoom in on it. Let's get real close over it, since this is our problem child here. So this very first fader, which is all the way up now, my focus is a little janked up too. All right, so very first fader. What happens if I try to drag this down? It doesn't go all the way down, and it does stuff like that, which we don't like. That's not very nice compared to all the other ones, which are nice and smooth and don't really care where you drag them. So what causes that? Well, more than likely, it's going to be dust and other contaminants, you know, other gunk that's mixed into the resistive track of the actual slider knob. Because even though it's a mechanical fader, it's still functioning in an analog way. It still has a wiper that's moving along a resistive track, which in turn is being interpreted into bits of data. So it's basically an ADC. It's taking the analog information of the fader, because yeah, you're still working with analog audio here. It's converting that digitally. And so
when the fader is mechanically gunked up so that the analog tracks of that wiper are not producing a constant resistance and a complete resistance, right? That goes from whatever that is, 0 to 100K, let's say, probably something like that. If it's only measuring, 0 to 90K, or if it's like jumping around in resistance when it gets to that bad spot, which is right around here, as it's letting me know. That's when you have that symptom. It's the same symptom I had in the Control 24. I think it's very common for these console mixers because it doesn't matter how great they're designed, you still have openings here that these faders travel. And especially with the aging of these devices, stuff gets trapped in there, especially if you're eating potato chips or whatever while you're doing your long mixing session, which you shouldn't do, by the way. And when I was in the studio, they were like, no food or drinks in here, which was a very good rule. This stuff is expensive. But yeah, that's a little rundown of what causes that problem, what I believe and my experience has caused that problem. And yeah, not much more we can say. It's a beautiful device, and I think these are cool if you can get one. So yeah, I think we'll leave it at there for now, and I'll make a part 2 of this. More to come. All right, so I finally got the problematic fader out, and boy, was it not a fun process, and in fact, quite a bit harder than the Control 24 I did back in the day. Whew! The desoldering pump didn't even work because the leads are so incredibly large on this potentiometer, which isn't necessarily a bad thing, but the part that is really annoying is to get this guy out of here. There's actually 2 very large metal mounting brackets, which of course mount to the main frame. Not the main frame, the main frame. And as you can see, there's these little divots that kind of pop into the cutouts here. And in addition to that, there's screws securing the fader knobs, potentiometers, on every single one of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 2. So you got to take out 30 screws. Then you got to use your pliers. And in this case, I used some needle nose pliers. And you got to push out the tabs on on one side, and then the other side you've got to use a heat gun. I'm sorry, not a heat gun, a soldering iron, because it's a ground tab and it's not isolated. It's fully connected to this entire ground plane, which will the copper will just suck up any heat you apply. So you've got to put direct heat with about 650 to 700 Fahrenheit of a soldering iron on there, and then use tweezers with the edge of the board to pull back each of those tabs. And then after you do all that, because the desoldering pump didn't work for removing the potentiometer itself, I did this desoldering stuff later. I had to go and then use a combination of a heat gun, a hot air reflow station, to heat this up, to warm this up just enough, and then go over the joints repeatedly with a chisel tip from my soldering iron. Boy, did that suck. That shouldn't have to be so hard, but it was. And here we are, back with our troublesome knob. I can put my clip leads on this. Actually, I should go ahead and use my desoldering pump to clean up these leads so I can, when I remount it later. But now the next step is going to be very similar to the Pro Tools, or sorry, not the Pro Tools, the Control 24 one that I did, which is squeezing out these tabs so that the 2 frames can split, and then you can go inside finally and clean the wiper thoroughly. Obviously hoping there's not like any major damage to the wiper. I don't know why there would be. One thing that's really interesting about these is you got this little pulley system for the mechanical faders, and obviously goes to this motor right here, and it's kind of nifty. I am kind of curious how the optocoupler sort of thing works, but maybe that'll be another time before I dive into this some other day, because I'm really tired and I want to get this done. All right, folks, back here with my fader repair for the DM2000, and this has been such an exercise in frustration, but I got some good news. What I've done, by the way, is I've used some hook probes, as you can see, and I've got it tied to my multimeter. And I'm going to show you a little test you can do to save yourself some headache. Something that I did to save myself some headache. So I'm going to put on the probe here. What I'm trying to check is to see if this resistive element works at all, or if the track itself has been too damaged, sort of beyond repair. I've gone in and cleaned out and kind of straightened out the teeth that are there. And from what I can tell, there's two tracks here that connect to these two pairs of teeth. The middle track, which doesn't seem to connect to anything, but the middle track itself, maybe it's this center pin that that connects across. Anyway, I've not tested the center. There's these 2 points on the center part. Maybe that's what that's the resistive element there, but I'm not sure. But at least the ones on the side I do know. And so what I'm going to do here is just kind of gently press down, trying to find the right alignment, and then I'm just going to glide this. And you see how my meter, I don't know if you can see that, my meter is changing ever so slightly, especially when I get the alignment right. And you want to get it to where you can actually 17K, 18K, 19K, 20K. So it's like going up just ever so slightly, which tells me that unless there's some clear dead spots in the track that I visually can spot, and I can't, the track is probably fine. The teeth are actually working quite well too. You want to make sure you don't have any scraping sound when you do this, of course, because that'll damage that resistive track as well. And that's all it is, right? It's just a potentiometer. So why this hasn't been working when I've been putting it all together, I'm not sure. I'm going to dig into that more. But the way I've found to put this together that seems to work quite well is I put our little slider guy in here. And you gotta go really slow. It's so easy to damage this old stuff. So go really slow, be really careful. One thing, of course, is the belt is not on properly. So gotta make sure I have the belt on like so. I do wish there was a, I guess it can't really slot in there. It's gotta be loose so the belt can move on the other side of the plastic. Because there's a slot, there's kind of a notch where the teeth actually lock into the black plastic, and then there's a slot that's just kind of open-ended, and that's the part that actually pulls. And so you've got this pulley at the end here that you wrap around like so. There is an orientation to this, so make sure that your two teeth match the kind of two tracks here on the top, and not the other way around, of course. And so, yeah, doing it like this, and then I kind of press it in. I load the PCB into this guy first, and then I press it in and very carefully wrap the rest of that belt around the motor axle here, the little gear. Anyway, I'll make another video when this is completed, because this is hard to do on camera. It's tricky, though, but I think I'm making progress. Continuing the nasty fader repair for these Alps faders for large console mixers. Look at all this crap I found. This was after thoroughly vacuuming and using my air compressor really thoroughly on all the faders. This is all the crap that was still inside, and there's still a bunch more. One thing I want to make a note of is I used a bunch of deoxit in here hoping this would help, and I really think that's probably the opposite of what you should do. Really kind of regretting that now, because it will gunk up these little fingers, these little contact fingers. But I wanted to show, this is actually a working one that I pulled because I just really needed a reference. And what you'll see here, the important part for me that I was really struggling with at least, is when this black plastic is flush against the metal frame, you should have quite a lot of Z height for these contacts. Gosh, it's probably like what? Maybe 2 millimeters. It's really got to go past that frame to reach the circuit board, which is surprisingly recessed actually. And so that's the problem I'm having. I also wonder if my little teeth are a little bit too loose on my other one, and of course the curvature here on the bend here I'm missing. So I'm going to try to bend mine into shape very carefully for the other one. Well, let's compare it actually. I can just show real quick. So for example, here's mine, which, yeah, the one I'm repairing at least. It extends. Ugh, it's hard to do this too with one hand holding the phone. So yeah, it extends a little bit, but boy, it needs some work. It's not looking too hot. See what I can do. Hey folks, back here with this most frustrating DM2000 console mixer fader repair. This is an Alps fader. These are, I don't know if they're common, but I think it's very similar to the one that was used in the other Control 24 console I repaired some years back, and boy, is this thing a freaking pain to fix and work on, but I think I've finally got it, or I'm extremely close to having it already. So I figured I'd save you all some of the headache that I've had to go through and explain what I did. Whew. Okay, so you got a few things working against you working on these. First off, you're going to get a bunch of dust and crap into those teeth there. That's the first thing, and you want to go extra slow when you work on these, and get yourself a nice pair of Rhino tweezers. Don't get the cheap stuff. And yeah, what you'll do is bend out the you bend together these little metal tabs. You bend them together. They kind of, you know, the gap between them, and then maybe you can gently push out if you need to on these, and then the two pieces will come apart and the board will come out. There's a plastic cap over the motor bit. There's a black plastic cap here normally, which holds the belt in place, so you can actually just angle it outwards and you don't have to undo all that. And if yours is not that broken, I would recommend just doing that. Mine was pretty jacked up, so I took the whole thing apart, undid that cap and took off the belt. And then when you do that, the belt runs over there's a notch in here, right in here, where the belt actually notches into, and then this is where it free flows. But you have to get the belt in both those passageways for the motor mech. So there's that. Next up, my teeth have actually shortened. They're kind of, I don't want to say they're brittle, they've just taken a lot of use. And I had to do a lot of really high precision kind of bending and tweaking with my tweezers. Really subtle work, kind of like working on an old watch or something, to kind of get these teeth straight. What you'll see is I've actually fanned them out ever so slightly, and I wish my camera was focusing better. Let's try this again. Focus for me, buddy. So ever so slightly, I've got these teeth fanned out to make better contact, because the thing that was also really working against me is there's some play here, not just in the x-axis, but in the y-axis. There's actually a little bit of play, and I don't know if this was intentional. I tend to think it wasn't. It's just from age. But you'll see if I push this little guy, let's try to hold it in place. You see that? It's very subtle. There it is. But this, you can kind of push this around between these two plastic posts that have been used to secure that copper. I think it's copper. Maybe it's zinc. But in any case, used to secure that. So there's a little bit of play there and crap. Try not to do that. Looks like I didn't do anything bad. I've been using my microscope for this, like kind of essential. So once I did that, I got pretty close. I also had to straighten out and then curve this guy, and I had to bend everything kind of further out because the tabs had broken compared to the longer elongated ones on this other one that I pulled out for reference. And I did have to take apart a whole other fader just for reference. Then I was, over and over again, reapplying this PCB on the top without the belt, just to do some testing with my clip leads, which I have hooked up to my multimeter, so that I could run this back and forth and see if the resistance changes accordingly. And what I found, to my great dismay, was that it wasn't, and I couldn't figure out what was going on. I thought the track was damaged, like the actual resistive element. It wasn't. I applied some, what should we call it, some deoxit, which actually did help somewhat. But, and then I thought, well, maybe it's the contacts aren't meeting because they're shorter, so I did a bunch of work around that.
That wasn't the problem either. What the problem was the x-axis alignment was ever so slightly off. I want to say by about 0.5 millimeter. I don't know why, because those plates look like they're aligned perfectly. I've even tried this with a different frame. I couldn't figure it out. What I ended up doing, which is a little risky, I try not to do stuff like this, but desperate times call for desperate measures. I ended up using a rotary tool to ever so slightly drill out these little notches. Just a little bit. And this was after a lot of testing, because I was finding that I would get proper measurements if this was just slotted in a little further down. And yeah, it's pretty wacky. So what I'm doing now then is I'm going to be rebending all the metal and getting the belt in there and everything too. But it's going to take a little bit of finesse work to get it in there with just that slight offset. Might have to pad it or something too. But with that slight offset, it is working. So, you know, don't mess with a good thing. But damn, that was hard. So, I'll post more on this later, but just wanted to give that detailed explanation. All right, here is what I hope to be a beautiful sight. Measuring the two most outside pins here. And I'm going to take this Alps pot. I'm just going to slide it very slowly. And it's changing resistance. I found maybe a dead spot. Maybe. I think I'm hoping the deoxit's fixing it though. Looking pretty darn good. There was one little jump. Part of it's the meter, of course, has to account for the changes and do its calculations. That's pretty darn good though. And that was the one that was damaged. Look at that. Oh my God, that was a lot of work. So let's put this bad boy back in. I gotta get the other one put back together as well. But I think I'm in pretty good shape. If I can get these two faders back in safely, I'll be in business.
All right, so I finished the fader repair. Oh my gosh. Not too much I can say. I'll do a little recap, but folks, this was really unfun. This was really unpleasant. This was like a 10-hour repair job. It was horrible. It's almost 5 in the morning. I'm still working on this. It's crazy. Anyway, it seems to all be working now, at least by my measures with my digital multimeter. And this one had kind of a stiff belt in the slider, and it turned out that was from gunk in the kind of the pulley that's over here on the top. There's a motor with a gear, a little gear bit, and there's a pulley on the other side. The pulley was kind of gunked up. So took that apart to do that, and also used this as a reference slider to repair this one. And this was the really bad one. This was channel 1. And what had happened is, just with these, they just get gunk in them, you know, just dust and stuff over the years. And when it gets really bad, it gets really bad. In the case of this one, it actually broke off a bunch of the teeth that actually slide on the resistive element. And then it did something that I actually haven't fully figured out, but it made it so that the track is just ever so slightly off on if you're looking at the camera this way, the y-axis here. And so what I ended up having to do was actually very, very gently drilling down notches, the notches that are already present in the PCB, so it can be shifted ever so slightly over. And that could just be the teeth being damaged as well. I tried to shift those a little bit too. But it's such a precise system that you really have to make sure that it's all working. I actually thought there were spots in the resistive track that were damaged. Not the case. Everything was fine, which was good because it meant that I didn't have to replace it and wait for parts. I could actually repair it, but it was not fun. And gosh, I think next time I might just replace it, honestly. Down here, the way you measure, by the way, is you measure, there's the 4 pins on the bottom, 4 pins, right? And there's 2 kind of grounding mounts that aren't connected to anything. The outer 2 pins are the resistor that you want to measure for changes in the resistance when you move the knob. And then over here, this is just your motor. Probably don't need to look at that. I don't know, unless your motor breaks, but it seems pretty unlikely.
The other thing to note is that you have to undo all of these screws after you've already done all of these screws to take it out of the main frame. And then once you're done with all that fun, you have to then pry out with some pliers each one of these tabs, and then you have to do the same down here, only these ones have solder applied to them, so you have to pry with a soldering iron and pliers at the same time. Fun stuff. You could try a desoldering pump, but it's such a massive heat sink that you're not going to have too much luck with that, I think. So that's what I ended up doing. Of course, it's also lots of fun. You have to get your screwdriver in through that hole to get this out of the frame as well. All those different holes down there. This was just a nightmare, and I don't. It's like they designed this and built this to make repairs a torture. You know, I don't know what was going on with Yamaha when they did this. Because, like, also, why is this board so massive? Like, the Control 24, I know it's later, but these are on individual boards. So you just pop out a board and replace that one. Why would you design a huge bank on a very expensive PCB, by the way? To do a full PCB like this is not cheap. But that's what they did. It's crazy, in my opinion, and really, really bad design. But that's what they did. We're stuck with it. So have fun repairing your DM2000. Avoid it if you can. I think from now on, what I'll do is, really recommend vacuuming. You really want to vacuum and dust out these faders on a regular basis. Like I do it every 6 months. I think would be a good way to do it, and really keep, avoid that kind of stuff from gunking up. And if you get a nice high-powered vacuum with a small nozzle bit, it shouldn't be too bad. But there you have it, folks. All right, I'm going to try to get this all back in. I might do the CR2. There's a CR2032 battery that's in there that I have an upgrade idea for. We'll see how much longer I can stay awake, though. So more to come. All right, back here looking at the inside of this dinosaur Yamaha DM2000 mixer. It's really quite the interesting beast. And having taken this apart yesterday, I can now have a little bit of a break from the anguish of it all. I guess working on this thing is it's so unpleasant. Not the least of which is these really old school 90s style cables. Let me show an example of what I mean. Let's get the light up in here. So one of the things I I hate working with these cables. It's so easy to just bend the pins out of place, and to get the alignment perfect is just, it's a nightmare. And there's 4 of them, and you can see how short they are from actually reaching the main board. And I don't have this open like all the way even. So it's designed in this crazy, crazy way. That said, there are some interesting looking circuits and cool 90s design in here. I love the larger chipsets, and it's cool to see just how many chips are in here. Like, holy mother, it's a lot of chips. This board's kind of cool. It's all resettable fuses everywhere, trying to protect your audio gear. Over here is the power board, and as you can see, it's actually mounted to the bottom frame. And I really don't like that. It makes it really hard to remove because you have to undo about 50 screws to get to this point and undo those 4 really short ribbon cables. And then you have to do like a bunch more screws to try to angle out this power supply. Like I said, it's kind of torture to repair. It's horrible. But it looks good quality at least, and none of the caps are swollen. It's nice and beefy. Look at those big transformers. It's cool to look at. So I'm going to be in here and putting the knobs back in place. By the way, I always love it when you got like weird vertically mounted circuit boards like this. That's the jog dial. And I don't know why they mounted it like that, but it looks cool. So yeah, I got all these screws to put back in to get the fader. The fader's all back in. Get those 4 connectors back in. Hope that nothing got damaged in this process. And oh yeah, I'm also going to be replacing the user save settings, which is this CR2032 battery right here. Might as well replace that since I've done all this work to get inside here. But yeah, well, hopefully I get this all back together. That
that goes to that connector. You see how short that is? That's ridiculous. But that's what they did. All right, I'll stop complaining and I'll get back to work. Here's the battery board in the DM2000 Yamaha mixer console, and you can see it's actually not a CR2032, which is the common 3-volt batteries you find. It's a CR2450, from what I can tell here. And I don't have one of those. It's very uncommon. So I'm not thrilled that I can't change that, but also, what you gonna do? So hopefully somebody else can learn from this video to get one of those first. All right, I pulled a second all-nighter, 2 all-nighters in a row to get this bad sucker working. Check this out. It's pretty darn cool, if I do say so myself. I'm gonna go over here. This is the instruction manual. I'm gonna load up Reaper. And bam! I don't know if you saw that, but all the knobs automatically, all the faders, go to their positions. We go ahead and close it, close Reaper, and they all go back, baby, including fader number 1, which is now fixed. Let's load it up again. Oh yeah, the ghost fader knobs. They're not knobs, they're faders. I'm tired. And here we go. Now let's see what happens if we can solo stuff. We can control it here. It's really cool. We've got panning, which by the way is a rotary knob instead of a potentiometer, which is pretty interesting. It means the panning is done digitally. This thing's also got a bunch of built-in equalizer. When you switch to these modes, this is pretty sweet. It gives you the readout. Pretty darn cool. All sorts of dynamic. Oh, it's got a built-in delay too. Anyway, lots of things to mess around with. It's a nice piece of kit. And it's working. Yay!